I'm going to talk about telling. Uh, I reality and opportunities. I think we have the resonance. Probably you mute your side, that side, then it will be good, I think. Otherwise, it's, okay. And then one is about the big data. First question is big data. Is big data really big? Okay, a lot of people are talking about the big data. But then we will evaluate if it's really big. And the second one is about how can we know whatever we learned from big data and actually would give us big value. And the third one is about everything online seems fake nowadays. And then, but also obviously it is not true. Not everything is fake. Then how can we tell? And this question will be answered by Kai Su, and he's a senior PhD student here. The fourth one is easy to evaluate data mining. Is it true? Is it true that it's very easy to evaluate big data mining? So we will present something like a question like this. Without ground truth, how can we conduct evaluation? So usually in the traditional data mining, we have ground truth. But now, if we don't have ground truth, what are we going to do? So this is a news piece on KD Nuggets. I also put this link at the bottom, and it says 10 free must-read books for data mining, for machine learning and data mining. Social media mining is one of them, and it's a freely available. Okay, it's a freely available online, this book. And later I will also show you other books and where to find this also. Okay, this is like we have two books. This is the one I just showed you. This is a textbook, and this semester I'm teaching in the senior undergraduate student undergraduate course. It's called the Social Media Mining. And we have another book. It is Twitter Data Analytics. It's also free. It has the code as well as the data sets for this book. And for social media mining for professors, we also, or for anybody, we also provided slides you can directly use and for your teaching. And the book is, both are free. You can download them for free. So graph theories, for this book, social media mining, we cover graph theories, network measures, and models. Then also data mining essentials. For the red colored phrases, these topics are mentioned in this book, Twitter Data Analytics. Briefly, they're all briefly. So it's very easy to read. Then we have community detection and analysis, and information diffusion, influence, and homophily. We just finished the recommender systems this week, and then we have behavior analytics. In behavior analytics, we need to cover like sentiment analytics, but it's not in this book. Sentiment analytics was briefly mentioned in this book. Now, I just try to talk about the first question. Is big data big? I try to show you that the big data is not big, okay? So that's why I have this making big data bigger, okay? And you probably know the answer, right? What is big data, for example? So usually the common answer, the conventional answer is 4Vs. So you know 4Vs. Huh? And what I want to say here is a practitioner's answer is not that simple, not just 4Vs, okay? I will show you why. So my point here is big data can be actually little or thin. It is not big. It looks big, but it's not big. And if small data alone is insufficient, right? If the big data is not big, it must be small. If it's small, how can we apply machine learning or data mining algorithms? So we need more and bigger data. Then I will briefly mention 2 lines of work. Make little data bigger. How can you make little data bigger? And the next one is how do we make thin data thicker? Okay, if in the audience, if we have social scientists, then you probably understand what I'm talking about, what thin data and thick data. Okay, but I will explain later. So making little data bigger. And I use feature selection as an example. So feature selection, if you try machine learning or data mining, you try these algorithms for big data. I still say big data. And then what you do is you usually, if you apply feature selection, you will see the performance improvement. Okay, usually it works. So what is feature selection? It selects an optimal subset of relevant features from original high-dimensional data, given a certain criteria. The criterion here, whatever you want, it's sort of like you can use it to optimize according to this given criteria. And often we use accuracy as the criteria. Now, this is the data. I just, it's of course, it's a toy data. It only has like 5 instances and 10 features. But you really like it. You can consider multiply by whatever large number along the number of instances or number of features. Well, I just use this toy example to explain the effect of feature selection. So now we have 10 features, but 5 instances. So the question is this data big? So if you just say, look at like so many features, right? So many features. I can multiply this feature by like 1 million. Say, if you work on bioinformatics, then it can be 40,000. Okay, but if you think about text, each column is a word. You can also make it very big, right? But now it looks like let's assume this is a big data, but I want to show you that this is not big data. Actually, this is a small data in terms of the space, the search space we have. Okay, look, if we do feature selection, if we can select the relevant features, the gray colored columns are relevant features. If we just select these 3 features, then we will have this kind of a data. And then I argue that this actually is bigger than this. Why? Okay, here is the space, right? So if you look at this, if we only consider attribute values are binary, and then this is the space 2 to the power of 10, right? So because I have 10 features, each feature can have 2 values. So it's a 2 to the power of 10. And I say this data is small because I only have 5 instances here, but the whole space is 2 to the power of 10. It's 5 out of 1,000. But after the feature selection, I really make it like the space much smaller. So it's only like 3 features to the power of 3. So 5 out of 8 is a lot of data, right? It's more than half. So I can definitely learn better. Then the next question is, does feature selection always work? And I'm very confident that yes, it is. It does. And for most high dimensional data. But then you ask, where can you find it, right? So I have this also, we have a tool, or we have a repository. It contains, it's scikit feature. If you know scikit-learn, then you can, this one is prepared for you to use with scikit-learn. And this an open source repository in Python. And it was last year, it was mentioned as in KD Nugget blog. Says 5 machine learning projects you can no longer overlook. Okay, so scikit feature was mentioned. If you are interested, you can go to my website, you can find it, okay? And scikit feature is an open source feature selection repository in Python and developed by our lab at ASU. So now I would like to talk about making thin data thicker. And most people, like you and me, most of us, are in the long tail. So this is sort of like a power law distribution. We have a short head here, but we have a long tail here. So the popularity, for example, this is like basically we are not as popular as other people. So in the long tail, we're not as popular. Here, the people are very popular. So they are in high demand. But here, we are here. So people like us, we don't have a lot of data online, right? So for each of us, we only have a very thin slice of data. But all of these companies, they really want to make money out of us, right? So if you think from the company's point of view, they provide money to these people, celebrities, right? They give them money, but they want to make money from us here. But from their point of view, how can they do this personalized service, provide a personalized service to you? They have to understand you, but like you and me. However, you and I, we don't provide a lot of data online. So very thin. How can we make thin data thicker? That's a research issue. So how can we do this? Social media data offers new opportunities. For traditional data, then nothing you can do. But for the social media data, we can do something. One is because social media data is of multifacets. For example, we have posts, we have profiles, we have linked information, as well as like, comments, all of these things, right? But then another source of additional data is multiple platforms. So you probably use Facebook, use Twitter, use Instagram, use Yelp, right? For different purposes. So, but we have accounts on these different platforms. So we can make use of these platforms. But then the challenge, what is the challenge? The challenge is how to connect users across more than one social media site. So for example, people usually look at my name, Juan. They thought I'm Mexican, okay? So yeah, it's Juan. And so if, let's say, if my username is Juan, and also it can be spelled as Juan and Huan. And are these two people the same person? Or the same person or same name can mean different people. So it's not easy to connect. And I have a former student, Reza Zafarani. He is now an assistant professor at Syracuse University. And his PhD thesis is about how can you connect people from different websites. You make sure that they belong to the different usernames, belong to the same person. Okay, he can do this. If you can connect the people, like usernames for one person, then you can collect the data from different sites, because you use different websites for different purposes, and you provide complementary information. This way, you can make same data thicker, okay? But of course, there is a privacy concern as well, right? And now, the second one is, I would like to talk about is making sense of big data, okay? Now, first, nowadays, we have big social media data. We want to automatically get a sense of what it is, right? We want to understand the user needs, their sentiments, their opinions, behavior, and trends. So a big part of big data is text. The examples I'm going to use are text data. So it's about natural language processing, okay? And text mining, we use natural language processing, NLP, and text mining techniques to help us extract topics from text. But this is like, okay, we use machine to extract, right? But we ask the question, if machine learned topics are for human consumption, are they actually comprehensible? Okay, so I can generate something nobody understands, but it does very well for machine learning. Nowadays, because machine learning can do very good job, so we also want to see like if they can also produce something understandable. So a former student of mine, he is now at USC, University of Southern California, ISI, Information Science Institute. He works over there as a staff member. And his PhD thesis, actually, part of the work is about measuring interpretability of statistical topics at scale. How can you study? How can you measure interpretability of machine learned topics? So there's a recent Journal of Machine Learning research article paper. This is like also freely available. If you are interested, you can just search this title, you will get it. Basically, we use coherence and consensus. But now allow me to dig deep and give you more detail. The big text data. Some examples, corpora. So Wikipedia, World Wide Web, and social media, right? These are already old statistics, okay? But you have an idea how like big text data can be. So too much data to read. How can we begin to understand all of these large bodies of text data? So there's a need for comprehensibility. So this is about the topic modeling. I use LDA. There are many other approaches you can do this. So let's say K equals 10. I want 10 topics, and I have many documents, okay? I want to learn from each document what are the topics of each document about, okay? So if I have like key topics, Then you have topic 1, topic 2, topic 3. Each topic consists of a set of words, then associated with how the percentage of their occurrence, presence in the text, okay? So this is like if you have documents, you decide you would like to have 10 topics, and the LDA will give you output like this. I have 10 topics for each document. We will give you the distribution of these percentage values, okay? There. So now the question is about how to measure interpretability. It is not easy, right? So how can you do this? We face a dilemma immediately. We can always ask language experts to help us, because the language experts are credible, but they are not scalable. They are expensive, right? They are not many. And another alternative, an alternative is crowdsourcing. So basically, you get onto like a platform like Amazon, Mechanical Turk, and then to pay a few cents for a question, but you can try to hire a lot of people to help you. Crowdsourcing needs no experts. It is scalable because a lot of people, they try to still make a few cents and for one question, but if they can do this efficiently, they can make some money. The problem is the crowdsourcing has no expertise. If it does not have expertise, then they're not credible, right? Whatever the results we get, not credible. So that's the dilemma. When something, or the experts, we can use experts are credible, not scalable. Crowdsourcing is scalable, but not credible. What can we do? So if you ask a good question, then there will be like if you ask a good question, there will be a lot of smart people out there to answer your question. So this is a very, very well cited paper. It's not our work, published in NIPS 2009. It says, the title is Reading Tea Leaves, How Humans Interpret Topic Models. So the idea is this. In order to understand these words in the topic, you need experts. But are experts too expensive? Then the authors say, hey, they find a better way. They said, okay, what if I just ask the crowd just to identify something that should not belong to the topic? Okay, this is the idea. Let's assume we have a topic, I. If you look at the blue words, they are all about animals, right? This is simple, okay? But there could be some more complicated cases so that you really need experts to tell you. But in this case, they say you can introduce an intruded word. That's called a truck. Instead of asking the mechanical turker to say how good this topic is, you just ask them to identify the intruded word. Because if they can identify, it's easier, much easier to identify the intruded word than to say if these 5 words are good quality words for a topic, right? So that's their idea. It's called the measure, it's called a model precision, okay? It's a very, very smart idea, right? So basically, after you find a topic, the topic has keywords. What you need to do is you just try to introduce an intruded word. Okay, just introduce a word that does not belong to the topic, and then you ask the Turker to check. So if the Turker, this is another example, okay, this is an example. All right, this is an example. So remember the intruded word. So what we have is if a Turker can figure out the intruded word, this paper says it is a good topic. Okay, so my student Fred, he got his PhD at 2016. I told you he is at the USC. He said that it may not be sufficient. Okay, this is an example. Two examples here. One example says English, language, Greek, word, century. Okay, and then drew. So this example says trading, exchange, stock, New York, the stock exchange, NYSE, market, cosmonaut. Okay, so if we look at these two topics, if we are asked to identify the intruded word, so we probably can identify cosmonaut or this one, Drew. Okay, but we can also see that the quality of these 5 words is different from that of these 5 words, right? Okay, then there's the issue. If you just use the intruded word, try to identify intruded word, you don't describe how good the remaining words are for a topic. Okay, so this is the idea here. Okay, so I need to. All right, so this one says, you see, this is more tight. Then tighter, this is tighter than this. And how do we, obviously model precision cannot just measure this one. How can we solve the problem? And because model precision only measure the distance, basically measure the distance between this word, intruded word, from the remaining words, right? But now we have an issue about the remaining words. What it doesn't model precision measure. It does not measure how tightly these words are in terms of their meanings. Okay, so we have a problem, right? So we need another measure. What is that? If we need another measure, it should not be too costly, right? Remember, we still need to use crowdsourcing, and we cannot ask our Turkers to do too much. So the suggestion here, Fred provided, is instead of asking Turkers to choose one word, intruded word, you ask the Turker, every Turker, to choose 2 words. Okay, you say that this is your first word, this is your second word. So do you see? You don't actually increase a lot of work for a Turker, but now you have 2 words. I don't want to talk about too much detail about the formula, but I just give you the idea, okay? So in this case, if we choose 2 words, right? We definitely choose the first word as truck, right? Because that's the intruded word. Then now we ask everybody. We usually ask Turkers, we have like maybe 10 or 20 or 30 Turkers. It depends on your budget. So it's not just one Turker, okay? So if you ask several Turkers to select the second word, they may choose different words, right? Someone can choose cat, someone can choose dog, because they are so similar. So what do you get? For the second word distribution, actually Turkers, because I have several Turkers, they cannot just to focus on one word, right? Because they work independently. So the first word is simple, but the second word they will pick like every word evenly. Okay, this is the distribution. But if so, this is like we can tell now. This is a good topic because the Turkers cannot differentiate the word, the remaining words. Okay, they can first word they can identify as truck, but the second word they cannot. What if I get this kind of a distribution? All the Turkers they can they select the second word like consistently. Okay, that means this concept, the topic is not as coherent as this, right? This distribution shows you the coherence among these remaining words. But this one tells you that Turkers consistently select the second word. That means the inner distance between the remaining words is big. So it's not as good. This is not good. So this is an example, okay? So you will see, like in this case, it's difficult to, first word is chosen. It's okay, possible not. But then second word is difficult for Turkers to choose. That's why even distribution. But for this example, Drew is the first word chosen, century is the second. Because English language, Greek word, they are all very similar, right? So this is the model precision can only describe this level of closeness. And the model precision choose 2, it can describe what model precision cannot. And this is an example. And basically, this slide says you have to use both. You cannot just use one measure. You have to use precision, model precision, and model precision choose 2. You have to use both. When both are good, then it's a good topic. Okay? This is like, in this case, it is, yes, people can find the intruded word, but they cannot find this the second word, right? So one of them is good, is still not good enough. All right. The third topic is about detect fake news. I won't dwell on this too much because Kai will talk about it. Okay, Kai published a very influential survey. It's called the Fake News Detection on Social Media, and it's published last year, already got 70 some citations. Okay, and Kai is a co-presenter today, and he will tell you more. And also he will discuss tools, repositories you can use, and we are going to give a tutorial at a Wisdom conference. It's called the Web Search and Data Mining Conference. It is a very influential conference, and in 2019 to 2019. Okay, it will be in Melbourne. Yeah, in the beginning of next year. It's a tutorial we're going to give. Oh, by the way, if you are working on this this line of research, and a former student of mine, he is Su Han Wang, this guy, and he joined Penn State as an assistant professor, and he is leading a workshop at Science Data Mining, and it's about fake news. So the call for paper will be out very soon. You can actually already find some information on my website. And it will be held in Alberta, Canada, in April, in May. Okay. All right. The fourth topic is about evaluation without ground truth. How can we evaluate something that we don't have ground truth? Okay, this is a CSCM article. You can find in the digital library of this, but you can also find it on my website. Okay, basically we just say, we give you example. We evaluate. We review the different works from different disciplines. We try to show that actually there are different ways to help us to evaluate when we don't have ground truth. So, for example, we can, in order to evaluate the question about when, where of things, right? We can go for these things. We can also evaluate the how of things. Then we do outcome evaluation, causality detection. See, for causality detection, we evaluate the why of things, how of things, when and where of things. When and where, it's about spatial and temporal, right? Causality explains why, and outcome evaluation explains how. So if you look at it, we have A/B testing, we have using how to use external sources, all right, and causality detection. And the article is freely available online, and it's from this communications ACM as well. Okay. So this is my last slide. Okay, I would like to thank you and thank Professor Romeo Sanchez for the invitation. And Scikit feature is an open source feature selection. You can find it. We also have an extensive survey published by ACM Computing Surveys, discuss all kinds of algorithms. Then we also have a social computing repository on my website. These are the books. Some of the books are from my lab. Social media mining, I already talked about. You can just get it for free. This is also, you can get it for free. When Romeo visits us in the future, I will give him a copy. Okay, but the soft copy is available online. And mining human mobility in location-based social networks. This another brief book. And this is a former student of mine. He's now a manager at LinkedIn. And trust. We also studied the trust in social media. Jiliang Tang, he is now an assistant professor at the Michigan State University. And this is the recent book about the feature engineering for machine learning and data analytics. And if you are interested in deep learning, and this book covers some of the techniques of feature engineering, okay, for learning. And that's all from me. And if you have questions, feel free to ask questions. Thank you.
Thank you. Are there any questions? There are some questions.
Yeah.
Thank you. Hi. Hi, I'm Andre. We are working in Iglo. Iglo is a company about social media. We are using Instagram right now. In the past, we use Twitter and Facebook. But I have a question for you. In Instagram, how can find the sentiments about the post in many purpose and some purpose. Now we have 40,000 comments about campaigns, but my question is how how information need to do these techniques. I saw your books, but my thing, my information is very is little for practicing these techniques or need more. And the second question is in YouTube, how measuring the sentiments. I think I read the comments, and when I read the comments, we apply a technique to find. But my question is in this case, exists another technique to find the sentiment, and you talked about the fake news, and are you working or what are you work in attempting to find accounts, but using bots to increase the follows, to increase the interaction.
Okay. All right. Thank you for your questions. I just try to answer your questions one by one. So the first one is about sentiment analysis, right? Okay. Yes, there are a lot of tools and a lot of books on sentiment analysis. Okay. And you know, so in this Twitter data analytics, that book, if you get onto my website, you just go to publications. I can show you. I can show you. So how do you get things from my webpage? So can you see my webpage now?
Yes.
Okay, good. All right. So see, this is the one, the first book, but the other book I didn't mention here. So you can just click publications, publications. Then we have book. Then it's this Twitter data analytics, preprint for free download. Okay. So in this book, we actually provide the source. So you can get more references from this book to your to address your this sentiment analysis needs. We also just use like existing to get these sentiment analysis. I used to have a student, he is now a assistant professor at Texas A&M. He worked on sentiment analysis, but nowadays we just use the existing one. And so now go back to your second question. It's not related to sentiment analysis. And it is it was fake news, and the guy he will talk about in more detail. Okay, about this. Then you also mentioned about bots. Yes, we have bot detection projects. We try to study bots and separate the bots, and then because bots can be harmful to sway opinions, so that's why we want to study. But we separate the bots, the work, bot detection from fake news. So usually fake news is a more complicated issue, and the bots are designed for different purposes. Okay, so bots probably they try to help spread of fake news. but not necessarily they initiate. So we, Kai, he will talk more about fake news. Okay, that's all. Any other questions?
One more question, yeah.
Okay, quite a nice talk. Thank you very much. I have this question. Your methods, in my mind, appear to be highly dependent on the knowledge of the nature of documents. But what happens, or how these methods compare if you use a simple kind of I don't know, neural network or something like that. If you have a set of documents that you know that are fake news and are labeled like that, and you just train some neural networks or something like that, how this compares to the method that you have presented today?
Okay, okay. So I think you are talking about neural networks, right? Yes, and I worked on neural networks since 1994. Yes, and if you go to my my publication website, you will see we did a lot of this kind of neural networks around. Let me see, around 1994 to 1999. During my time, I worked in Singapore from 1994 to 1990, the end of 1999. So I collaborated with an expert in neural networks, Rudy Setiono. So we worked on neural networks, okay? So yes, if you have a lot of data, then you can use deep learning methods to do very well. But that's the ideal case. In reality, we don't have a lot of data. Okay, in reality, for fake news, it's very challenging. That's why Kai, he will talk about all of these things, like why it is challenging, why you cannot just. He will introduce some methods of neural networks. Okay, he is using all of these things, but still the bottleneck is not these tools, these algorithms. The bottleneck is more about the data. Okay, the ground truth, like who can be the authority to tell us this is fake, this is not fake, right? So it can be very subjective. So then even, let's say it's not a subjective matter, but how can we get the data and how can we get the label the data? I will let a very good question. So I will let Kai talk, and his talk will focus on fake news detection and all the challenges. Okay.
Thank you. More questions? One last question, Dr. Liu.
Sure.
So, usually in conversational forums, we are always talking about many topics, not a single one. So we see that the techniques that you presented today are basically identifying or clustering, keywords that represent a topic. So how generalizable are these techniques to, to extend to end topics, or some of the topics may share some of the keywords or the text, or may share some properties. So is it possible, or what is the current station on generalizing the identification of topics in conversational social forums or something like that?
Yeah. Okay. So yes. It's because the social media data, right? You said the conversational, all of very, very challenging. And we have more questions, more problems than solutions. So it's, for today, my talk, basically just try to present some the challenges I see. And I actually pose more questions than solutions. We have done very little about solutions. And especially like in my lab, every PhD student works on one direction. When they leave, they brings the project with them. So they basically, so it is like there will be more work to do. So for example, Ben, and he is an assistant professor at Texas A&M. He already has like more than 10 PhD students working on things he is interested in. He tries to work on explainable deep learning, for example. And yes, a lot of problems. I just try to present some challenges we face. Hopefully we stimulate thinking and see how we can work together. I have Saul with me, and he is working on feature selection in clustering. So that's he's studying a PhD student, right? Yeah. And he is a visiting student from Mexico, and so we are collaborating on feature selection for clustering. Thank you, Romeo.
Thanks a lot for your participation today. So we are ready to listen to Kelly.
Oh, you want to use mine? Oh, you have to use yours, right? Okay. So it's hold on. Maybe we will connect. This. You have it actually. We are connecting. We are connecting. Hold on.
Okay.
You already have the email, right? Romeo. You check this email. I know it's here. We are connecting through the right, this one. Romeo, Kai is connecting with you through Skype another channel.
Okay.
So I just log off. Okay.
Okay.
I'm in the same room, so if there's any question, I'm still available.
Okay. Perfect.
Thank you.
Dejar de grabar.